Hey guys, so we're going to do some examples, some further examples of expanding and condensing logs. I look at it as like putting like solving a puzzle, taking things apart and putting things back together. So hopefully you'll see it the same way. If not, hopefully this will make it a little bit easier for you. All right, guys, so here we are on our first set of first two examples of expanding logs. I want to go ahead and write in here, not only are we going to expand, but I also want us to simplify where we can. All right, so looking at our first example A, the first thing I want to do is talk about, I'd like to identify how many parts I have. The first thing, so I know I have 100, and I have an X. They're being multiplied, so I know that's going to end up being addition. I also know that means I'm going to write the word log 2 times. And then I know it's not here, but we know that the base is going to be a 10. I'm going to go ahead and write the base as 10 in here just so you can see it, and I think it'll make sense to a lot more people. So we're going to have log base 10 of 100 plus log base 10 of x. Now, the directions say that we want to go ahead and simplify where we can. And to do that, let's take a look at this log base 10 of 100. Now, I know I can simplify 100 to where I could have a base of 10 with a power of 2, which is good. So that means I can take and bring down this log base 10 of 10 squared, meaning our identity properties earlier told us that if the log base 10 and the 10 match, then our answer would equal 2. So 2 would be the simplified version of that plus log base 10 of x. So you could write your answer 2 different ways. I would accept either 2 plus log base 10 of x or 2 plus log of x. Either one would be great. All right. So moving on to example number 2, we have log base 2 of 2x divided by 32y. So the first thing, again, I like to do is identify how many parts I'm dealing with. So I have a 2 that's being multiplied to an x, so I know that's going to end up being a plus. Then I have a divide symbol, which means I'm going to end up subtracting. And anything that I subtract that's in the denominator will always have a negative in front of it. So I have a 32 times a y, so that's 2 parts. So I have a total of 4 parts. That means I'm going to write the log base 2 4 times. So let's get started. We're going to have log base 2 of 2 plus log base 2 of x minus log base 2 of 32. Now remember, that's in the denominator, so the next part will also be in the denominator, and we're going to go ahead and put minus in front of that. So any part that's in the denominator, minus goes out front. So minus log base 2 of y. Now, again, with the directions, it says it wants to simplify where we can. So let's take a look at each part and see if we can simplify anything further. Looking at the first section, the first term, we have a log base 2 of 2. Remember, if the terms are the same, then the power is going to equal 1. So we're going to have a 1 that's going to come down. So we have 1 plus. It doesn't look like the next term has anything going on, so we're just going to bring it down as log base 2 of x. And then let's take a look at log base 2 of 32. Let's see if we can do anything here in this little section. Let's look at 32. We'll look at 32. We know 32 is the same as what? 2 to the 5th power. So that means I essentially have the log base 2 and 2 that are the same, meaning my 5 would be left. So I have minus 5 that's going to come down. And then I have minus, it looks like log base 2 of y. Nothing's going to happen here, so we'll just bring that down. Minus log base 2 of y. Now I'm kind of just looking at it again, looking for like terms. I have a 1 and a negative 5. If we combine those, that's going to give us a negative 4 plus log base 2 of x minus log base 2 of y. And that would be your final answer. All right, so here we are with our last two examples of expanding and simplifying logs where possible. So our next example, example C, we're going to look for any parts that we have. Notice we just have a ln, our natural log of x squared. Now, x squared is not being multiplied to anything or subtracted. The only thing here I see is that we have an exponent that's not supposed to stay there when we expand. Remember, it's going to have to go out front as our leading coefficient in front of the natural log. So our only thing that we're going to do for example C is move that 2 out front. And so we'll have 2 times the ln of x. And that's it for letter C. Let's go on to letter D. So we have a log base 3. Again, let's look for our parts. We have 27 times x squared divided by 4y all to the third power. So we have a lot of things going on here. But for parts, we have 27. We have an x squared. We have a 4 times the y. Now, all of that is inside to the third power. We'll break that down in a second. But I know I have at least 4 parts. That means I'm going to write the log base 3 4 times. So the first thing we're going to do is just kind of break it apart. This is going to take multiple steps to kind of get it all done. So let's just start from left to right. I have a log base 3 of 27. And it's being multiplied to x squared. So we'll put plus log base 3 of x squared minus, since we're dividing now, and everything afterwards will come as a minus log base 3 of 4 to the third power, because we're taking that 3 and it distributes as an exponent power to each of the things inside the parentheses, minus log base 3 of y to the third power. All right, so for the next part, that we're going to just take and evaluate each term to see where we can simplify or not, or move things around. So the first term, this log base 3 of 27, I'm going to see if we can do something with this 27, if we can make it with the same base as the log base 3. So if we have a 3 to the third power, that would be 27. And so I could bring down my log base 3 of 3, meaning that we're going to the log base 3 and the 3 leave me with 3. And then we're going to look at the next term. We have log base 3 of x squared. Now on this one, the only thing that looks like we have to do on this one is take that exponent power, move it out front, and rewrite it. So for this term, we're going to have plus 2 log base 3 of x. And then the next section, let's look at the next term. We have a minus log base 3 of 4 to the third power. Can't really do anything with the 4. I can't change the base of that one. So all we're going to have to do is move the exponent of 3, again, out front of the word log. And so then we're going to have, for this one, we'll say minus 3 times log base 3 of 4. And then our last term, let's evaluate that one and see if there's anything we can do with that. Again, it doesn't look like anything, so we're going to take this 3 as an exponent and go put it in front as well. And that will give us our last term of minus 3 times log base 3 of y, making this our final answer, our simplified version in expanded form. All right, so here we are with our first 2 examples of condensing logs. So we're just going to be working backwards. Instead of breaking it apart and writing the log with the base multiple times, we are now going to take that log and base and only write it once. And then we're going to, if it's an addition, it'll become multiplication. If it's a subtraction, we'll make it into a division. And we'll be looking for any powers that we can move out in front to the exponent position. So looking at letter A, our first example, I have the log base 4 written multiple times. So off to this side, I'm only going to write it once. I have log base 4 one time. So I'm going to kind of mark those off. I know I've written them. I now have a plus in between a 2 and an 8. That plus will become multiplication. So now I have log base 4 of 2 times 8. And if we simplify that, then we know 2 times 8 is 16. So we have log base 4 of 16. To simplify, you can take a look at this, 16. Can we simplify that to where we can have the same base as this 4? If we take and put 4 squared, that would give us the same thing. So we would have log base 4 of 4 squared. That means that that log base 4 and 4 cancel, leaving me with this 2. So our final answer would be 2. All right, so looking at our second example, we have a log base 2 of x minus log base 2 of 5. I know I'm going to write the log base 2 one time. And so I'm going to mark those off so I know I've done it. This subtraction is going to become division. And then that means I'm going to divide the first x is going to go in the numerator. The 5 will go in the denominator. So I have log base 2 of x divided by 5. All right, so I'm going on our last two examples of condensing logs. If we look at example C, we have 3 parts. The first part is separated by a plus. The second part is separated by a minus. Remember, anything with a minus is going to be division. Anything with a plus is going to be multiplication. It looks like on each one of these examples, I have a leading coefficient out front of each of the word logs. So just to help me, I always like to go and draw a little arrow about where it's going to go. That 2 is going to become the exponent of x. This 1/2 will become the exponent of z. And the 5 will become the exponent of y. Now, it might be helpful for you to rewrite that information underneath, and then we can kind of condense it in just a second. So right now we have log of x squared, and then we're just going to bring down the plus for now. Then we are going to have a log of z to the 1/2 power minus log y to the 5th power. So let's go ahead and take our parts and start condensing it, and then if we need to make changes, we can do that along the way. So we're going to go ahead and write the word log out front. Remember, none of these have bases written, so they're understood to be a 10. We know that the x squared and the z to the 1/2 are being multiplied, so those are going to be in our numerator. So we have x squared, z to the 1/2, all over y to the 5th. Now, let's look at that again. Is there anything that we can simplify further? Actually, there is. We can actually take care of this 1/2 and rewrite this 1/2 with the z as square root of z. We've learned that in the past. So our final answer would be log of x squared times the square root of z all over y to the 5th. And that would be our simplified condensed log. All right, so here we are with our final example. We have 1/2 times the log base 2 of 64. I don't see anything being separated, so that's fine. The only thing I see is a leading coefficient out front of this. So we have this 1/2. That means that we're going to have to take that back and put it and make it an exponent of 64. So we can rewrite this real quick as log base 2 of 64 to the 1/2 power. And just like the previous example, this 1/2 power is actually the same as the square root of 64. So let's rewrite this as log base 2 of the square root of 64. Can we take that and simplify it further? Absolutely. By this time, you know that the square root of 64 can be rewritten as 8. And that would give us log base 2 of 8. And we look at it again. Can we simplify further? Why not? So I'm gonna bring this down here so we can see it. We have log base 2 of 8. Can we take this 8 and rewrite it so it has the same base as the 2? We would have what? 2 to the 3rd power. And that would give us log base 2 of 2 to the third power, and the log base 2 and 2 would go away, leaving us with just the 3. And so our final answer is 3. And that would be our simplified or our condensed log. And here's some words of advice just for to take away from all of this. There are multiple ways that you could see this and do it as far as what process or what procedures. There's not a right or wrong way what you have to do first. As long as you can get to the answer and you feel comfortable in the way that you work through it, that works best for you. So if you go out there and look at different examples on different videos, you'll see a plethora of different examples getting to the exact same answer. So hope you have good luck with all this, and we'll see you next time.